students. In this session, we are going to continue operating system overview. The second part of your first unit will be the operating system structure. So, we are going to see operating system structures with the subtopic system calls and different types of system calls and system programs and few topics on operating system structures. So, you have a textbooks that you can follow. So these are the textbooks. Operating System Principles. So this is by Abraham Silberschutz and Peter Galvin. So we call Galvin textbook, which is 7th edition. This can be preferred where all 5 units are covered in this textbook. Okay. And for reference, if you wanted to do any advanced programming like Unix and all, if you want to work more on coding, then you can go with this textbook with Stevens. Okay. Advanced Programming in Unix Environment by Stevens. So, in the second unit, operating system structures, we are going to cover these subtopics. Operating system services means what are the different services that are provided by the operating system, and user operating system interface, and this is how the user is running with, or user is interacting with the system with the help of different APIs. So, how you can use the system calls for using these APIs, and what are the different interfaces you have so that you can use system calls or programming you can do, and what all the operating system services can be provided, all that can be achieved. Then coming to once interface you are known, then we are moving to the system calls, how the system calls are being used and what are the different types, and system programs, how to write a system program using the above one, the system calls. Then operating system design and implementation, how you design and how you implement using different sort of APIs and different sorts of system calls in different structures of operating system. Like in Unix, you will be using different APIs, and in Windows, you are using different APIs. Then finally, operating system structure, where we'll see the layered approach, something like this for different operating systems. And we also know what is operating system debugging, and we'll try to know what are the operating system generations and how the system will get booted. So these are the few topics that we are going to cover in this session. Myself, Dr. Shirisha, Associate Professor from CSE Department, MLR Institute of Technology. So what is a command line? Command line is a command interpreter. CLI is nothing but a command interpreter. So it allows a direct command entry, sometimes implemented in the kernel, sometimes by the system program. Okay. Suppose if you want to create any directory, what we'll do, we'll give mkdir, right? Like that. If you wanted to print any statement, so any file content, so cat, if I give some file f1 dot or f1 dot txt, something like that, then that will get displayed. So what are these? These are the commands that you are going to give to the command line, where you can extract or load the contents. Okay. Sometimes multiple flavors are implemented. Multiple flavors is like writing a program, writing a script. So where we need a shells. So you all use for Unix or Linux operating system, we use the shell script. So that is shells. Shell script is where to write a different programs. Okay. Primarily fetches a command from the user, executes it sometime, commands built in, sometimes just names of the programs. If the later adding new features does not require shell modification. Means whatever the command line is not a GUI. So that what happens is, whenever the command is given, that command directly, it will send some system calls to the kernel and it will be executing. And if you see the GUI, it is user friendly, where we don't find this user friendliness in the command line or command interpreter. So what happens here in the desktop, it's a metaphor interface where you usually use mouse, keyboard and the monitor, and it represents the files with icons, programs with the icons, and different actions can be performed like creating, opening, closing, editing, and modifying the content, updating the content. So these are the different file modification commands that we have. And various mouse buttons over the objects in the interface cause various actions. So these are known, various actions means what you do. We provide the information. We have different options, like if you give ls -l, What is ls? Ls is to list all the files. List all the files. So minus L means it will be displaying all the particular files that are been in the current directory. So like that, there's the option and execute function, exec and open directory. Directory is nothing but we create when you have one directory here. So this directory will be having multiple files. This is file 1, file 2, file 3, so on. Up to you can save any number of files in a directory, so that whatever has been related to one particular context, so all that can be at one place, so that files can be organized very easily. Your file system should be maintained and organized timely, time to time, so that it can be fetched and loaded very easily, so that you can know the location very easily. And invented at Xerox PASI, so this is where GUI has been introduced. And many systems now include both the CLI and also GUI interfaces. Suppose if you go with the Linux operating system Ubuntu, okay. So if you use this Ubuntu, if you open the desktop of that Linux operating system using Ubuntu, you can operate using the GUI, and also you have a terminal where you perform a command line operations. So these two are also possible in the Linux operating system. So like that, timely, there are some updates. Previously, they were using the Red Hat for Linux operating system, that is completely a GUI based. Completely a command line based, where we need a GUI to perform few activities. So what they have upgraded to Ubuntu, where both CLI and also the GUI are possible. So Microsoft Windows is GUI with command line shell. That's all that we know. And Apple Mac OS is Aqua GUI interface with Unix kernel underneath, and shells are available. So 3 are available here. Unix Linux has CLI with optional GUI interfaces. So as I told, few softwares of your Linux operating system may have only CLI, like Red Hat. And if you perform in the Ubuntu, you have both the GUI and also this command line. Okay, so that is about GUI and the command line, and they are also been upgraded to touch screens. If you see here, most of us are using Android or iOS mobiles today. Even your laptops are also got the touch screens, where touchscreen devices require new interfaces, and mouse not possible, not desired, actions and selection based on gestures. So what you do, and you perform your fingers, so that 2 fingers to zoom out, zoom in, so like that some sort of gestures has to be given. And virtual keyboard for text entry. Virtual keyboard is where you get a keyboard in the mobile or in the laptop itself with the keys. You are not going to give it from the keyboard, just to provide more security. Mostly we'll be seeing this sort of virtual keyboards in the banking applications or internet banking, where they can provide security by using this virtual keyboards. And voice commands. Today every website or every every organization is using a chat GPT. We use chatbots. So chatbots are nothing but where the users can give a vocal commands, voice commands, so that they can get then and there they can get the solutions for that. So this is how it has been upgraded. And moving further, I just wanted to give a small intro about the system calls, and types of system calls and system programs we'll be seeing in the next session. And in the session, we have seen what are the different operating system structures with the different interfaces, and what are the different services provided by the operating system, so which are very important. Services is one of the long answer type question. And coming to CLI and bash process and this GUI interface and command line interface, they may be asked for the short answer type questions. And here system calls. Coming to system calls, if you remember this diagram, system calls is acting as interface between the user and between the UI and between the services. So this is in the terms of user perspective. This is in the terms of kernel perspective. So in between these two, what is acting as a intermediary? So this is the system call. So what system call is doing? System call is connecting both the user and the kernel. Okay, that varies from timely, means work to work. Whatever operations you are doing, based upon the operations, this system call have different types that we'll discuss. So there's a programming interface service provided by the OS, and it is how obviously it is written in the high level language. We may perform this either in the Linux or in the Windows operating system. Also, system calls are used to provide the services by the OS to the user, mostly assessed by the programs via high-level application programming interface, that is APIs. Okay, and three most common APIs are Win32 API for Windows, POSIX API for POSIX-based systems. As a Linux or Windows, we call it as a POSIX-based system, where we use a command line mostly. Then Mac OS and Java API for the Java Virtual Machine, JVM. Okay, so these are the few APIs we have. So for Windows, mostly we'll go to the Win32 APIs, which is compatible to perform different command lines in the Windows operating system. These are the few examples. When you have one source file and when the destination file is there, so these are the things that we can do. This is just an example. So how do you call and what you perform? What are the operations you may perform when you have the file? Okay, acquire the input file. So first you need to know what is the input file and where is its location. Then acquire it, get it. Write prompt to the screen. Write some commands and accept the input. Okay. Acquire output file. To acquire output file, what we do? We write the prompt to the screen and accept the input just to perform a write operation. Okay. Open the input file. If file does not exist, abort. Otherwise, create the output file. If file exists, also abort. So, if open a file, if there is any file which is stored in a particular location, f1.doc, if it is there, then only you can open this. If this file is not there, then what you have to do? You have to create it. So, these are the two things which are interrelated. Then loop. Now you have a file, you have created it. After creation, what you do? You have to open it. Once you will open it, you can perform read from the input file. If there is a content in this, you perform a read operation. Otherwise, if you wanted to edit or append some text, then you can perform a write operation also. There's a write to the input. Until read fails, close the output file. What you do? Once you have opened it, finally what you do? You have to save it and you have to close it. So for all these, what are the operations and how they will perform the operation is by using the system calls only. Okay. After that, write completion message to the screen and terminate. So once you acquire the file and finally will terminate it. This is just one example where system calls can be used. This is an example of standard API. Means we are talking about services, system calls which are using the user interfaces, and the intermediary is system call. Now system calls are stored in the APIs. So standard APIs consider read function. This is one system call to perform what? Read function. That is available in Unix, Linux operating system. API for this function is obtained from man. Man is nothing but to help. Man read means what is read operation that can be given by help. So what is read? Read is a function. So read is a system call. That's a function name with the following parameters. What are the parameters? You have to give the file descriptor, okay, to perform a read operation. And what is its size, buffer size, and how many times, the count. Okay, all these three are the parameters that you have to pass for read. And where these read, write or any system calls are stored is unistd.h. So that is a header file you have to use. And what is the type of read function that is returning is size. This is a return value. So int fd is a file descriptor, buffer is a buffer size where data is read into, and size count, maximum number of bytes to be read in the buffer. So on successful read, whatever the number of bytes read will be returned, otherwise it returns an error, that is a -1. This is one of the example of read system call. Similarly, you will have a write open, close, any sort of operations. And how do you implement it? So number associated with the system call, we call it system call interface, maintains a table indexed according to the numbers. And when you perform one operation, that is updated into the table. Okay, all the operations that you perform. It is interface invokes the intended system call in OS kernel and returns the status of system call and returns the value. If it is successful, it returns the number of bytes or the output, and if it is not successful, it returns -1. So the caller need know nothing, okay, about how the system call is implemented. Need not means they have to understand how the system call will be implemented. Just needs to obey the API. Internally, how it is going, it is none of our business. But how this API has to be used and where it has to be used, that only you have to understand. What OS will do as a result call. Most details of OS interface hidden from the programmer by API that we don't know. Managed by runtime support library. So what is the library that we are using for read operation? unistd.h. So like that, based upon the system calls that you are using, we have to import such packages or the header file, so that all those libraries can be used and they can be compiled. Okay. So this is about how the system call is being implemented. This is the most useful reference for how the system call can be written and its syntax. And this is a relationship already we have discussed. A system call is the interface between the user and the kernel. So this is the kernel. So user is when he has to open the system call. So the system call is sent to the kernel. So this is the index table where it is showing where exactly the system call or file is there. Then it goes and search for that particular file, and that file can be opened. This is the implementation of open system call. So what are the two modes? Two modes is user and the kernel. Kernel mode will be 0, user mode will be 1. So whenever it is there in the user mode, the bit is changed to 1. Whenever it is transferred to kernel, this 1 will be changed to 0. This is the two mode context, means dual mode operations of an operating system that we have discussed in the previous session. If you want, you can go and check that. Okay, recollect that on dual mode operations on operating system. So this is one example where you can show the relationship with the help of the diagram. Hope you all understood. If you have any doubts in the topics that already covered, you can go back to my session 1 and 2 on operating system, so that this will be the continuation for them. Hope you all understood. Thank you.